Hi, I'm the Practical Developer and this is Messaging with RabbitMQ and Spring Boot. This video is based on an article that is in the blog, which is called Sending and Receiving JSON Messages with Spring Boot, AMQP and RabbitMQ. And Ali will explain you how to set up a basic project using this tool, how to send and receive messages using the default format and also JSON. Let's start with the default format and creating the application. So I'm going to use the Spring Initializer website. Then I will create a skeleton project, giving it a group name, an artifact name, RabbitMQ example, and the only dependency that we will need for this project is RabbitMQ. Then we press generate the project. Then we open the zip file that we downloaded. And we open it using the IDE that we want. In my case, I will use IntelliJ IDEA. I'm going to open it from the console, pointing to the POM XML file. And now if we open the POM XML file, you will see two dependencies, the test dependency, but also the Spring Boot starter AMQP. And what is this? If we go to the POM file that is defining that starter, you will see that has Spring Messaging and Spring Rabbit. So the starter for AMQP is containing the RabbitMQ implementation. We're going to need also the JSON dependencies. So here I will copy paste the three dependencies that are the basic ones for JSON. If we want to use annotations and data binding. And then let's create our class that defines the message, practical tip message. I will include a text, a priority, which is a number, and the boolean secret. And I'm going to use some shortcuts in IntelliJ to create the constructor, the getters, and a toString method. Now we open the RabbitMQ example application, which is our main class, the one annotated with Spring Boot application. And we are going to create some basic RabbitMQ configuration. For that, we are creating three constants having the names of the exchange, the queue, and the routing key. Now let's create them. So first, we are going to create a topic exchange. And that's very straightforward. We just need to use the constructor and pass the name of the exchange. Same thing for the queue. So we are going to return a queue, and then the only thing we need to do is to call the constructor a passing name. For the binding between the exchange and the queue, it's a bit more complicated, but we have a helper class. So as you see, it's going to be very easy. So we are going to use this binding builder class, and we are going to bind our queue to the topic exchange with a given routing key. And that's it. Well, actually we need to annotate the methods with Bing, because what we want is these objects being injected in the Spring application context. So that's the basic configuration. Let's now create another class because we want to send messages. We will call it practical tip sender. Let's make it a service. And to send messages, we are going to use the RabbitTemplate class. RabbitTemplate is a very useful class. You could see it as similar to the REST template if you're familiar with web services. And what it does is it provides a lot of helpful methods to send messages using RabbitMQ. So we are going to inject it using the constructor in our class. Then we are going to create a method sendPracticalTip that will create a practical tip message. It's hard-coded. and then we want to send this message. We will use a Rabbit template, and as you can see, there are many methods. We are going to use this one, convert and send, given an exchange name, a routing key, and then an object. For this sample application, given that we need the exchange name and the queue name, let's make the fields public so they are accessible from other classes. In a real-world application, you may want to include that via configuration. And then we just pass the exchange name, the routing key, and our object. In this case, is the tip. I'm going to include here also a logger, so we can see after we send a message that the message has been sent in console. And I'm going to use an annotation here, schedule, because what we want is that this message is sent more than once. So I will schedule this message to be sent every 3 seconds. And for that annotation to work, we have to add to our configuration enable scheduling. So very simple. Once we start our Spring Boot application, every 3 seconds, a practical tip, in this case always the same, it will be sent to the same to the exchange and routing key that we use. Now let's create the listener, the part that will receive the message. This is going to be also a service. I will include a logger here just to print in the console that we received a message after we receive it. And this is a different approach compared with the sending, because in this case we don't need a Rabbit template. We can create a method and annotate it with Rabbit listener, indicating the queue that this Rabbit listener is going to consume. And now the message that we are going to consume, the type of the message, we are going to use org Spring Framework messaging. So this is kind of a parent class for all kinds of messages, and what this is going to do is that it's going to provide us not only the payload of the message but also the headers. And we are interested in the headers because then we will see how the default serialization format differs from the JSON serialization format. And then the only thing we are gonna do with this message is just printing on the console the toString version of it. We have configured the sender and the receiver of the messages, so let's now run the application. To execute RabbitMQ, what I'm gonna do is I'm gonna create a Docker Compose file, and then the idea is that we can instantiate RabbitMQ in a Docker image. So in this Docker Compose file, I need to include an image name there. So I'm gonna Google a bit for a RabbitMQ official image, and there it is. So this is an official repository, so that's good. The name of the image is RabbitMQ, and we can use the latest version, which is 3.7, but I'm going to use a 3.7 Alpine, which is a reduced version of a Linux image. So let's use RabbitMQ 3.7 Alpine. Let's get some Docker Compose parameters like the hostname, the port that we are going to expose, which is the default one from RabbitMQ 5672. And now from the terminal I can just run docker compose app, and that will download the image in case that we don't have it yet, and then start the Docker image. So there it is, server startup complete with 0 plugins. That's fine. And can we just run the application now? Because Spring Boot is going to connect by default to the default port 5672. So okay, let's try to run the application and see what happens. Oops, exception. What's this error about? Well, as you can see there, it's complaining about the simple message converter only supporting string, array of bytes, and serializable payloads. And our practical tip message is none of the three, but that's very easy to fix because we can just say that our practical tip message implements serializable, so it can be serialized as a Java object. So let's run the application again, and yeah, it's working. So now we are receiving messages every 3 seconds, and yeah, this is a representation of our message. It's a bit difficult to read, but if we go to the content type header, we can see that it's a X-Java serialized object. So as you can see, the default configuration is serializing and deserializing messages using that format, which is fine, but we are also interested in doing that using JSON, and for that probably we need to know a bit more about what the simple message converter is doing. Now, to fully understand what's going on here, let's see the message converters in detail. So when we run the application, we saw that this is printed as a generic message class with a payload and some headers. And the payload is just the to-string representation of our object. So the mapping from the message to our class is working, is being interpreted as a practical tip message. Let's have a look at the Spring AMQP documentation, and let's try to find information about the default message conversion. So the first result is the official docs. Let's open it, and let's try to find here some info about the message converters. And there it is. There is a whole section for that, and we even have description for the simple message converter. So this is the introduction, and then under the simple message converter paragraph, we can read that this is the default implementation, and this is the converter that will be used by an instance of a Rabbit template if you do not explicitly configure an alternative. It handles text-based content, serialized Java objects, and simple byte arrays. So let's have a look at that class, at the simple message converter. We have it in our class path, and IntelliJ can even download the sources from the IDE. So I'm going to open the simple message converter class, and let's have a look at it. So this class has basically two important methods. One is to serialize objects to messages, and the other one is to deserialize. So this is from message, which is deserializing from a message to an object, and this is create message that will do the opposite, from an object to a message. And we can see that it has some branches, if it's a string, if it's serializable, which is our case, and then it will just serialize using the standard serialization method in Java. And it will tag it as a content type serialized object, which is the content type that we have seen before. When deserializing a message using the from message object, it will go through this branch. Content type is not null, and content type is an X-Java serialized object, and it will just use the deserialize method to do this. And the interesting part is that it's creating an object input stream, and for that it needs to know what is the class that is going to be used to map that message, and that's being done by that method resolve class. So let's debug our application, and as we can see here, it's resolving this full name of the class, practical tip message, which is inside the headers of the message, is finding the class based on that in our code base, and then is deserializing that message to that specific class. So let's remove the breakpoint and let's go back to our code base. And now that we know that the serialization is working, we can just use our practical tip message class here. Then we will just receive the payload instead of the complete message containing the headers. But that's fine because now we know that it's working. So because it's typed, we can use the specific methods. Let's print only the text of the tip instead of using the two-string representation. And as you can see, it's working. We are just receiving the tip text. Now let's try something different to see what's the disadvantage of this serialization method. I'm going to copy the practical tip message as a practical tip message copy. It's exactly the same fields. It's also implementing serializable. And what we are going to do is we are going to send the practical tip message object, tip, but I'm going to try to receive it as a practical tip message copy, which, well, you might think that it should work because it's exactly the same structure. If I run the application now, I will get an exception, and the exception is telling me that it cannot convert from practical tip message to practical tip message copy, which is kind of weird because they are mostly the same, but it makes sense because remember that we were including in our message the type of the class, the full package name and the class name. So the simple message converter will try to convert to that class, but it can't because the message is saying that it's a practical tip message, not a practical tip message copy, and that's why it's not working. Imagine that we have the listener in a different Java application. Then we have two options. Basically, if we want to use this serialization method, we can either put the class in exactly the same package name, so when deserializing, the simple message converter can find the class, or we can also do a trick, which is intercepting the message before deserializing it and changing the type so it can find the class that we want to deserialize to. But instead of doing that, we could also change the serialization format to JSON, which is widely extended and is much more flexible. Because if you think of having a consumer that is not even written in Java, then how are we going to deserialize a format that is very Java specific? It's very tricky. So that's why most people use JSON to serialize and deserialize messages. So let's delete the practical tip message copy and let's use JSON converters to serialize and deserialize our messages. As you can imagine, that implies adding some configuration inside the RabbitMQ example application. But before doing that, let's revert some of the changes that we did because now we are interested back again in having a look at the headers. So we're using the Rabbit template to convert and send the messages. That's the configuration that we want to change to produce JSON messages, and also when deserializing the class that we are going to set back to message so we can see the headers. Now, what's the configuration that we need to add? Well, it's basically about changing the way that we convert classes to messages and vice versa. And that's done with this JSON to JSON message converter. So first, we are going to change the way we produce message. And for that, we just need to have this being injected in the context, JSON to JSON message converter, and then configure the Rabbit template. So we don't use the default one, but we use one that is defined by us. So we construct a Rabbit template, and we are going to set the message converter to the one that we just created, the JSON to JSON message converter. And let's try with this first configuration. It's not going to work, but let's see why, and then we will understand better what we need. So if we create a Rabbit template without doing anything else, it will complain about a connection factory being required. So that's easy to fix. That's because the Rabbit template requires a connection factory, and the connection factory is already there in the context, so we can just inject it and pass it to the Rabbit template. And now we are getting a different exception, which is that the practical tip message cannot be converted to JSON, because JSON has some funny ways of working with the Java structures. So it's telling you that there is no creator or default constructor, so it's complaining about not having an empty constructor, but because I don't like that, instead of an empty constructor, I will just type the one that we have, so JSON can understand how to construct this from a JSON message. And the only thing I need to specify here is the names of the properties in that JSON structure. There are some automated ways of doing this, but let's do that in the example because it's, I think it's much clearer. And now if we run the application, hey, it's working. We are receiving messages after configuring the new converter. Now, as you can see, it has been properly mapped to a practical tip message and then wrapped as a generic message. But the most important part of it is not the payload, because the payload is exactly the same. It's the two-string representation of the class. But now we know that it's traveling through RabbitMQ with content type application JSON, which is what we want to do. That's perfect. It's working. So because we know that this is working, I don't need anymore to map as a generic message. I can convert it directly to a practical tip message, same as before. And we can print just the text, and this will work. So the only difference now is that the message is being converted to JSON instead of default Java serialization. So we have the text here. Okay, that's great. And now we can try the same thing as we did before, and that will show us the difference and the advantages of the two. So let's copy the class simplified practical tip message, and this is the same as before, It's just a copy of the message because I'm not doing anything else yet. We're going to send the message as a practical tip message, and we are going to try to receive it as a simplified practical tip message. And the difference now is that it's working. Why is working? Because now is the JSON converter the one in charge of serializing and deserializing, and JSON can serialize and deserialize as long as we have some fields that are mapping the JSON structure, and we told JSON how to do that. Even more than that, I can remove some fields and just keep the text here. So then I will instruct JSON to just deserialize the text. So let's regenerate it to a string method as well to show only the text. And now the idea is that I want to receive the message as a simplified practical tip message with only the text field, which might be useful if you have multiple consumers, but not all of them need the same information. If I try to do that, that works as well, and that's perfect. But there is a bit of magic here, because in JSON you would still need some configuration to make this work, because how is possible that I'm only using one field and this is just capable of deserializing it? Well, as you can see, this is a simplified practical tip message, so it only contains this method. Now I don't need this serializable interface because JSON is serializing and deserializing, so as you can see we don't need it. That's obvious because we are not using the simple message converter anymore. So we have a look at the converter, this new one that we are using. You will see that this magic that I was mentioning before is being done in the constructor. So it's configuring it to not fail on unknown properties. And this is something that is a bit of magic because the default behavior is failing on these unknown properties. So let's do a bit of renaming as well, because now it's not only the producer, but we know that we are also consuming using this message converter. So not to confuse us, let's rename it. And what I'm going to do is I'm going to specify explicitly an object mapper to this message converter. So then we can customize the mapper to do what we want it to do. And what I'm going to do is to instruct JSON to fail on unknown properties. So I'm going to use my own object mapper instead of the one that is created by default inside this JSON object mapper. And we change the message converter for the Rabbit template, and because we only have this field, now it should fail because there are two unknown properties. And yes, there it is. Now it's complaining that there is an unrecognized field priority, which is the first one that is finding while trying to deserialize. So that's perfect. And there is one thing, well, it's telling us that it's not marked as ignorable. Yeah, that's fine. There is one thing here that I don't even need to specify this, because if I'm creating a new object mapper, by default it will fail on unknown properties. So I can also say, let's create a new one, let's pass it, and then because it's not using the one customized by the JSON message converter, it will also fail. So to make this work again, if you don't want to use the magic that is inside the JSON message converter, you could annotate the class with JSON ignore properties and then ignore unknown true, which does exactly the same, but only for the classes that we specify. So now if I run the application, it will work. Using your own configuration for object mapper is normally a good idea, because you may want to specify how to serialize and deserialize dates, optionals, numbers, etc. And that's it. If you want to know more about messaging with RabbitMQ and Spring Boot and how to use this to model an event-driven architecture, I recommend you to have a look at my book, Learn Microservices with Spring Boot, which will tell you how to start from scratch modeling a microservices architecture supported by event-driven patterns using RabbitMQ, from a small monolith to a distributed system of multiple microservices. And if you have feedback about the video, do not hesitate and leave a comment in YouTube.